For most of us, AI compute tends to connote images of giant data centers using gigawatts of power and equally large air conditioners keeping it all cool. In fact, we did a whole episode on how AI data centers are driving major changes in real estate and civic planning. So if you're interested in that, make sure to check out one of our past episodes. But as AI use cases mature, the center of gravity is starting to shift as businesses demand lower latency, secure and scalable intelligence and insights. Edge AI is now fostering the development of new approaches to on-device compute, enabling a new class of applications that can address some of those concerns around latency, bandwidth, and data privacy. Hey there, and welcome to the AI Forecast. I'm your host, Paul Muller, and join me along with leading companies and industry experts as we explore the past, the present, and the future of data and AI in the enterprise every week. And if you haven't already, I would ask a huge favor of you. If you could just take a couple of minutes out and leave a 5-star review, we really do appreciate the support that it brings us. And speaking of support, I couldn't go on without issuing a huge thank you to the show sponsor Cloudera for bringing this podcast to life. They've been incredible. Well, back to today's topic. With everything we've learnt about AI over the last decade, and certainly with everything we've talked about on this podcast, could we imagine AI hardware and software to be decentralized and even portable? To answer that question and more, I'm joined by Chief Software Architect for Blaize, Val Cook. Now, Val knows a thing or two about blending hardware and software, having worked for over a decade helping lay the foundations for Intel's foray into the hotly contested GPU space before joining Blaize, where he leads the design of Blaize's graph streaming processor software programming environment, which we're going to learn a bit more about today. Welcome to the podcast, Val.
Thank you very much. It's good to meet you, Paul.
It's great to have you here. Where do we find you in the world today?
I'm in San Jose today, one of our stateside offices.
Superb. Hey, before we jump into the topic of decentralizing and even miniaturizing, shall we say, AI at the edge, we do a little thing called the Fast Four to get us warmed up in the mornings, or the evenings in your case. You ready to play the game?
Certainly.
Excellent. I love it. All right. First question. What would people who know Val best say is your superpower?
Now, that one's a tough one. I'm pretty sure it's
family friendly. Keep it family friendly, Val.
It's not growing hair. I've been using the same barber since I was 18. I'm quite sure of that. Probably thinking, just innovating. I'm the guy that likes to drive with the radio off, look at the world myself before I go looking at and researching how others do that. That's probably the thing I like to do.
In and around you, I'm the guy who listens to podcasts while he runs. So to be frank, it's important because it keeps me in a job.
That's a good point.
Moving swiftly on, what would you say the most impactful technology of all time is? And you can go as far back or as weird as you want to.
Well, I know what others say, and I'm probably not too innovative here. I definitely think it's the transistor. I think it's just changed the way that we see the world, that we interact in.
It's never been an answer here before, so you're the first with that one. We talk about AI all the time in the context of what it's going to do for everyone else, but what would you like to see AI do for you personally in your future?
I envision a collaborative effort, something that I learn to trust, something that I almost consult with, in a sense, where I'm able to articulate thoughts, ideas, processes, procedures in ways that can be critically reviewed, help me see reality that sometimes I can't see in the ruts that perhaps we fall into.
Oh, I like it. Very thoughtful answer, unsurprisingly for someone who thinks. Last but not least, we all work with data every day. Some of us are better at it than others. What would you say are some of the best practices or hacks that you've learned as someone who works with data every day? What makes you effective with data?
Certainly clean it, and all that goes with that. I'm sure you've heard that many times. Maybe the last kind of offbeat one is I have found trusting your intuition sometimes really works. We, of course, like our decisions to be data-driven and our results to come through that space. And sometimes intuition does provide some insight that you wouldn't have gotten to in a reasonable amount of time otherwise.
Yeah. So can we talk about that for just 1 second?
Certainly.
It's a philosophical question now, because we've done a couple of podcasts now on whether AI is going to, I'm going to make up a word here, dumbify young learners and by inference the population in general, the working population as they enter the workforce. I suppose the most relevant analogy would be the introduction, I suppose, at first of the calculator into the classroom, ultimately then the computer into the classroom, and now AI into the classroom. And we heard the case for it not being a problem. I still have this feeling that my intuition, and I do agree with you, and it's not really intuition, I suppose it is a series of neural pathways that have been slowly but surely reinforced over time, let's call it what it actually is, are informed by rolling around in the problem, by rolling around in the data, by sometimes having to do the hard, whether it's math or the creation process myself. What are your thoughts on that? Do you think potentially by over-relying on these technologies, we might be short-circuiting, or maybe not short-circuiting, we might be breaking some of that intuition?
There's definitely an element of laziness that I think can come into the picture that's going to probably bifurcate us in some ways. Meaning, a friend of mine put it very succinctly. I liked what he said. With the ability for AI to perform and quite well, by the way, the implementation elements, the performance elements, the action elements of our daily lives, whether it's writing or copybook editing or coding or some dominant areas that are being influenced by AI today. The process of doing that is it's easy to sit back and let that just happen with limited amount of effort on our parts. And my friend's comment was simply this. He said, I think it's going to come down to this. Ideas are going to become the valuable resource. And the execution of those ideas is probably going to be a diminished element of our society in the future. The skill sets that we search for, the proficiency that we search for, those may be diminished. And the people that are willing to invest in the creative elements, the thoughtful elements, the investigative elements in whatever your efforts and endeavors are probably those ones that are not going to let themselves slip into the lazy path. They're gonna force themselves to move.
Sort of the notion, as it were, of the idea economy rather than the knowledge economy.
Yeah, I like that expression. Yeah, exactly.
Fascinating stuff. All right, well, we might get you on to do a philosophy podcast episode at some stage. Look, I think it is one of those moments where we will look back again. It's rare to be able to sense that you're in the middle of these things when you're in the middle of it, but I do think we will look back and say, there were some smart choices made here or not in probably as little as 20 years' time.
Yeah, certainly agree.
Let's jump into it. Take us a bit through your background before we jump into the topic of the changing nature of edge AI.
Kind of a hybrid, long before there was a hybrid education. Background in hardware, undergrad and computer science, graduate, Brigham Young University. The sort of breadth of the education has been a real bonus for me. From there, I really worked in the GPU side of the world extensively. I fell in love with 3D graphics. There's a long story cut really short. My father brought home a bunch of videos from STI at the time, and they were simulation videos. And he let me watch them as a 12-year-old kid until about 1 or 2 in the morning. And I was just fascinated by that. And it became a driving, motivating force in my life as I trudged through, algebra and trigonometry and calculus and all the way through, always trying to figure out how to model this and how to model that. And I found that compelling. And then computer vision became a significant part of my life, both formally in education as well as career. And that's been enjoyable. So we helped with my co-founders and partners here, design GPUs at Intel for many years. Found that to be very challenging in the sense that the objective there was to do as much as you can in the available space. And it was much less about fitting the market and more about fitting the available resources. And that produced its own rewards and its own challenges. I appreciate your smile there. Thank you, without making me say what I just said.
We don't need to fit the market, we need to fit the die.
Exactly. How much white space is there on this device?
Which is beautiful in its own challenge. I mean, it is unique to, well, I was going to say to that company, but now invariably GPUs are built into every CPU, or almost every CPU. So it's, I suppose, blazing a trail, weren't you?
Certainly a fun experience, and I enjoyed that immensely. So thank you.
I love it. And you made the big shift to, as you say, do something brand new here at Blaize. Now let's talk about the mission, because I think the mission is certainly the thing that's of greatest interest to myself and I think our listeners. Let's talk about Edge AI versus, well, I suppose whatever its inverse is, to apply a bit of Boolean logic. Give me the NOR version of
Okay.
what is Edge AI, and how do you how would it characterize it as different from what we'd consider sort of traditional centralized AI?
I think there are two elements to it. One is the stuff that we think about often: latency, bandwidth, kind of all of those elements that engage sort of a device that might be distributed. I think the second element, and perhaps the more important one, is we've really come to enjoy the benefits of a consolidated environment, the cloud, right? Where the details are obfuscated, the complexities of really managing a sophisticated system are frankly something we choose to pay for rather than develop ourselves. Distribution to the privacy, all of those things become factors that we're willing to let others manage. And I think that there's certainly a place for that, and that's certainly a good thing. The edge then becomes a little bit more difficult to define if you want to think of it as a lower power device sits next to the sensors that are sampling its environment. That's certainly an easy definition. But if we look at it from a management software point of view, it may include enterprise. It may include air-gapped defense deployments. It may include server configurations that really want to have that same kind of benefit of the cloud in terms of managed environment, but simply can't. And so I kind of see it from both perspectives, I guess.
I mean, because obviously you can connect sensors to the sort of what I had to use the word traditional for something that's probably less than a decade old, but let's call it the more common version of cloud in most people. Sorry, cloud of AI in the cloud in most people's minds. I can, get a sensor, deploy it remotely. I can use wireless technology to get the data back to it. But we've obviously got this issue of latency. We've also got the issue of the fact that I may be relying on a third party to process the data rather than processing it myself, with all of the, the security implications of that. But there's also, I suppose, we talked a bit about this sort of power element of things as well. It's a topic we've kind of circled around a little on the show, which is there is this assumption that AI needs to, AI compute needs a tremendous amount of electricity, or, whether that's in the form of a battery or the grid to be able to run. Is that a consideration as we think about Edge AI as well, as just the energy footprint?
Absolutely. Yeah, absolutely. Of course, the latency-sensitive mobile applications, I'm talking autonomous navigation, robotic control, that kind of thing. Certainly that's true. I also think that's going to be true. We see it in each generation of our cell phones. We see more and more AI hardware being dedicated to the power budget and the die area in that device. And so, I think that's absolutely part of the story for sure.
Let's talk then about the case for Edge AI. So let's imagine that I'm in a boardroom, we're having an argument about, let's just go long on a big centralized play, double down on our expense with whichever provider we're using, economies of scale, all those good words. And someone pipes up and says, well, have we thought about Edge AI? Talk to me about the sorts of problems that Edge AI could uniquely solve that the sort of centralized play couldn't.
One area where we're finding a great deal of success, and it's what I call the dynamic sampling environment. And then there's maybe a secondary one that might be interesting to just toy with for a minute. The areas of the dynamic environment ones, they have to do with not necessarily having an immediate latency response, but needing to have a data-dependent response. What do I mean by that? Something as simple as I'm monitoring a platform at a subway station, and I'm running many video analytics in that environment, and I want to detect potential hazards. I want to detect incidents, slips, trips, falls. I want to detect bad actors. I may want to detect vandalism. And there are many activities that are happening in that scene. Many of them are conditional. If someone's standing close enough to the wall to be spray painting the wall, maybe I better run my pose detectors and my action recognizers. If they're not, well, let's not do that. If I'm looking for bad actors, probably don't need to run my face recognizer unless I've got sufficient number of pixels in the face detection, and so forth and so forth. And so what you see are these very fluid, very data dependent or scene dependent, in the case of video analytics, kinds of operations where round trips are just not satisfactory. And even if I don't need face recognition at 30 frames per second, the ability to not waste the energy to find out if I need to do face recognition is the critical piece there, right? Just the data movement itself, as well as fundamentally the data compression, right? When we can make more semantic decisions closer to the sensors and provide those results back again in semantic form, we can save a lot in terms of cost and in terms of real latency, not necessarily in the response, but in the energy required to produce that response.
What's wrong with the current architectures that needs addressing? I mean, it seems we're able to do on device today. Why can't we continue down that path?
Having designed GPUs for many, many years, there are a couple of fundamental low-level architecture pieces, and maybe we can jump into it a tiny bit. Let me touch on them. But most of them, if we were to draw a spectrum of high throughput, low latency devices, we might put CPUs in one corner. If we go to the other corner, we find an interesting position, and that is GPUs have high throughput, but they're not very latency sensitive, and they pay for that in the sense that they have a tremendous amount of data parallelism available to them, whether they're processing graphics or neural networks or HPC kind of work. They have a tremendous amount of parallelism available to them. This in-flight work costs you something. It requires persistent structures on the die and so forth in order to achieve that. So GPUs, particularly in the graphics space where there's an abundance of data parallelism, have large persistent structures, large FIFOs, large control queues, and so forth that allow them to keep track of a lot of information in process before they produce sort of their final results. Well, it's turning out that you need a much tighter control in modern architectures to run AI efficiently. Now, transformers, of course, have changed some of that in recent years, but the key piece of that has been to stream that data through the device. And, we've named our device a graph streaming processor, but under the hood, it's fundamentally a data flow machine, a coarse-grained, high-throughput data flow machine. And with that, we're able to do things like process data without needing heavy bandwidth. We're able to process data without needing really large memory words or really large cache lines. And batching isn't really a factor for data flow machines to achieve nice flat linear speed up. And those kinds of things are just uniquely valuable at the edge with newer style architectures. And we see that in multiple offerings in the market today, all that I'd share. The edge piece then of your question is really how do we do it in a conditional way, in a way that supports this large latency that comes with requesting some data from memory, processing other work while we're waiting for that data to come back from memory, and then at the same time suddenly need to turn left or suddenly need to turn right in the hardware architectures, right? And that becomes the challenge. And speculative execution is, of course, the answer in the low latency CPU world, but what is the answer in the high throughput machines that are highly data parallel, where you've got so much in-flight work? It's not clear that that's trivial or that our traditional architectures are able to address that well. And we're quite pleased with the way Dataflow types of architectures are handling that.
one last question then on the technical side of things, and I appreciate you taking the time on this. You're rethinking the hardware. Often the hardware operates best when the software is sympathetic to it. So would it be your position that we need a new kind of software architecture to do this effectively as well?
I'm a bit of a history buff, and it's very, very interesting to go back and look at seminal hardware architectures over the last 30, 40 years and line those up with seminal transitions in software. And there is almost always an alignment with both of those. And if there's a misalignment, they tend to not become significant. For example, rules-based architectures came along with the original Dataflow machines, functional type programming models. Well, an interesting thing happened, and you really alluded to this early on. Most of our semantics, our grammars associated with AI today are graph-based in the sense that the traditional ML frameworks and so forth all describe that work with the graph, and it kind of gets down projected into a scalar or a vector description of that data flow graph. And that was one of the key really decision-making points when we chose to build a data flow architecture was, is there a software infrastructure that will map well, or will we find ourselves spending all of our time and resources building compilers, right? And it became a lovely reality that the descriptive grammars of the up and coming, if you will, at the time, AI types of workloads mapped very nicely to the hardware.
Your software architectures, you just got this graph stream processing, is a software development model or a philosophy or a suite of tools or all of the above?
All, actually. But yes, we just give you for example, it carries clear into the hardware architecture itself, where the individual processing elements, we were fortunate enough to get two of the key hardware architects that very familiar with designing custom processors. We're not using off-the-shelf processors, but they've got quite a few unique characteristics. But one of those was hardware-to-hardware device communication. And so in a data flow machine where you see that kind of data moving through the chip in a data-dependent fashion, and it became really, really valuable.
Thank you for taking the time on that. There's obviously more research for myself and our listeners to do. So let's talk about results, because it's one thing to have a new paradigm. It's another to get something from it. Where are you seeing edge AI type applications, I guess, deliver results? The canonical example I often hear for edge AI is automotive, because of course you want a car that's going to be able to, sense traffic lights changing or a deer jumping in front of you, whatever it might be. Kangaroo in Australia. Are there other edge cases beyond auto?
Absolutely. Yeah, I kind of alluded to one. Dynamic video analytics, security, surveillance types of scenarios are turning out to benefit tremendously from those. And again, it has to do with the dynamic environment. Let me suggest there's one more, and it's as much a software as a hardware piece to the story. But when we come across a new opportunity, the storyline with the potential customer almost always goes to this kind of narrative. I really wish I could do this, or I really wish I could do that, right? And if you start to look at this list, and then you look at the list of sort of the menu with your 10 items on it of what you've pre-built for the customer as, demonstration or enablement capabilities, we're getting less and less of an overlap. And we're talking with the customer looking at parking structures and security in the parking structures. Well, you can imagine you would want to detect speeding and wrong way driving and some of the traditional things, tailgating through the barriers and so forth. They wanted to know if someone was sliding under the vehicles and cutting off catalytic converters, right? They wanted to know if someone had slipped on a little oil spill that had not been cleaned up in the facility, right? And incident management kinds of things. And I guess the point I'm trying to make is that the highly specialized, sophisticated analytics were becoming increasingly at the tip of the tongue of these customers. Can you do this? Can you do that? Can you do this? And even today, you can go look at a Gartner report, sort of the spectrum of what products provide what video analytics capabilities. And the list is surprisingly small. Maybe 20 to 30 items are on that list. And yet we hear this highly specialized request coming from the customers. And the answer can't be professional services, right? It's got to become more than that. Well, how do we get there? And especially, how do we do that on the edge, right? And so it truly is both the hardware ability to run highly varied workloads and then the ability in the software side to describe that and even allow the customer to describe that.
And so, I mean, at the risk of being cliched about it, this is an innovation opportunity as much as anything, because what you've described is, hey, you could go and buy someone else's, off-the-shelf video surveillance capability, but you're going to be limited to what that hardware and software combination are capable of doing. If you want to take your product to the next level, you're going to need effectively a clean sheet design.
Exactly. And really rewinding to your point about the programming models, the software programming models needing to match the hardware architectural innovations. You can imagine that the code generating capabilities of LLMs today and the ability to describe our workloads not as a series of stateful register programming, kind of, I'm even going to say this, GStreamer style static declarative representations of workloads or video analytic functions. Because our languages match our hardware, we can generate those languages, and we're able to essentially allow a customer to describe what they would like to accomplish on the chip in natural language.
I've got a couple of questions for you. You mentioned programming models. At the risk of sounding doom and gloom, I go back to, you're a history nerd, so the transputer might mean something to you if I mention
Certainly.
the transputer.
Yep.
Perfect.
Yep.
So a wonderful bit of hardware and software architecture that, incredible stuff, fell at the hurdle to a degree because it kind of required you to adopt the software programming model at the same time as the hardware, and that became a limitation. Am I going to need to throw out all of my tools and my tool chains to adopt something like GSP?
Yeah, I could give you the cliche answer, but let me give it to you in practical terms.
Please.
We chose to use a global unified address space. In Dataflow machines, it is very attractive to use distributed localized memories for each compute element and not allow them to share. It gives you lower latency, higher throughput to your persistent storage structures. But we knew that I couldn't compile a C program to that kind of hardware architecture, right? We knew it had to work in the real world.
It sounds like you've done a lot of hard work to make everyone else's life simple. Now let's talk about, we talked about innovation earlier, I mentioned it. What do you see as the biggest opportunities for innovation in Edge AI? Like, what are some of I'm sure you've done some yeoman's work, and I'm sure you're looking at what competitive capabilities are out there. If we look at the domain space as a whole, what are some of the big opportunities out there that seem like persistent problems you're looking forward to cracking?
I'm going to stick my neck out just a little too far on this one, and let's see what happens. But I'm
excited by this.
I genuinely think, well, let me give you an example. I've had a chance to do some vibe coding lately, and it's been really fun. It's been fun to kind of shed the details of the syntax of a particular language and focus on the task I'm trying to get accomplished. Sometimes in that experience, I'll ask it to do a very compute intensive task, and it'll churn on it for minutes. And if I ask it to do it again, sometimes it comes up with an interesting idea. It says, hey, how about if I write a Python script to do that, and then we'll run the Python script. And so instead of working on my task, it writes a new piece of code. It validates that piece of code. It then runs the code on my data, checks the results. If it doesn't like it, it restores my data, modifies the script, runs it again until it gets it right. And it can do that substantially faster than it can just running it through the LLMs. Right? Well, why is that? And a friend of mine once said, why does it take 1 trillion instructions to add 2 plus 2? And the answer is, well, maybe I should have written a program that adds 2 plus 2 and run the program and then if I need to do it again, I can run that again. Right? So I think there is a ability to use very rich capabilities that we have today in a hybridized way, in the sense that let's put the right kind of compute in the right place and get the benefits of kind of, is codifying an applicable word in this space, maybe codifying what I ask it to do so that it doesn't have to figure it out every time, right? And I think that hybridized world is going to be a huge innovation. We see major players investing heavily in that. We see Apple putting a lot of compute in their handheld devices with exactly the intent of hybridizing the communication between these devices. And I think we're going to see that innovation in a really broad spectrum of both our human-machine interactions as well as much more sophisticated aspects of life, where we can, we just can't afford to put a $10,000, 1,000-watt device in our pocket, right? If that device that does fit in my pocket can answer what I need to know, but more importantly, it can know when it doesn't know, right? That's the hard one. Does it not know? And then it asks the big brother upstream, right? Help me with this one. And I think those are both the innovations and the challenges that are coming. Is going to be, how do we build a distributed world with distributed compute that meets the power envelopes that are available at the various edges and central places, and then work collaboratively.
It was going to bring me to my other question, which is edge versus centralized AI an or an and? And it sounds to me like you're in the position of and.
Absolutely. Yeah, absolutely. I really think it's going to come to that we'll see more and more of the codification of work to be done when it's static, and then clear abilities to know when and how to work collaboratively.
AI has found that GPUs work well for the problem, but are not, to your point, optimal. Do you see a future where someone's going to completely clean sheet an architecture, a hardware and software architecture for AI, both in a central and decentralized sense, or are we at a nominal state in your opinion?
I don't think so. Histogram of gradients is only 7 years old. CNNs are only 5 years old, where they started to see the demise. Transformers do you see what I'm saying? I think there's just going to be the horizons we see today are a lot more optimized, conditional execution, MOEs, for example, in large LLMs, and all kinds of techniques that are really beginning to optimize and reduce the compute requirements of sort of our let's call them our brute force techniques of yesterday. I don't think we're going to find that. I think the trick is going to be to balance the programmability and the flexibility of the device against the power and throughput requirements. And that's always a trade-off between those two. Is you don't want to get stuck trying to ride a wave that peters out, and you also don't want to be, so you build more programmability and flexibility in your device, but you also don't want to be in a place where you're not competitive from a throughput and power consumption point of view.
Wow. Okay. So it's conceivable we could see another, I guess, ARM famously kind of developed out of a small and beautiful, very purposeful vision of the future. You see room for another ARM, another architecture that could be transcendent in this new world as we come to understand it better.
Yeah. And historically, it's very interesting to see how often those sort of fundamental transitions come from the small to large path versus the large to small path.
Yeah, I love it. It's wonderful. Val, I can't thank you enough for joining us. If people are interested in learning more about Edge AI, or for that matter, GSP, where can they go to learn more?
Blaize.com, Blaize.
All right, well, that's a wrap. Does AI make you edgy? Would love to know. Drop your thoughts into the comment section, or hit up Cloudera on LinkedIn using the handle @Cloudera with your thoughts. Thank you again to Cloudera for hosting another episode of the AI Forecast, and thank you again for tuning in. We'll see you all next week.